viewers, today I will show you how to modify the output voltage in these 32 volts HP power supplies. Interestingly, the designers of the PCB were kind enough to leave an empty space for an extra resistor, so it's only a matter of calculating the right value and soldering the tiniest package there is, and of course finding the right empty space. You know, it all started recently when I bought these 30 watt ProLight Opto LEDs, and they really got my interest since they can produce 136.4 lumens per watts with minimal color rendering index of 95, and all of this for only around €2 a piece. Of course, only later I found out from the datasheet, from the actual datasheet, that the superior efficiencies reach only at lower powers, around 10 watts I think. Nevertheless, it's still a nice product, nice LED, but at max power voltage drop is around 35 watts. I bet you're freaking, so what? The voltage drop is irrelevant if LED driver is used, aka current source. Yeah, sure, another 20-30 euros extra cost. I don't know. Here in East Europe, Dumpster Dive might provide you this nice 32 volt HP power supply for free. So most printers use this, I believe. And this one I found without cable, because copper is valuable scrap material, right? Fortunately, the person that took that wordless cable left me this. The caps are nice. I didn't test them though, but looks nice. The package is well sealed, never there's few taps with hammer or pressure in vise, and the wall would break. Also, there was this. Okay, so switch power supplies share many similarities. For example, better ones always have feedback loop where output voltage is compared with some voltage reference. The driving chip then tries to minimize the difference by changing the frequency or pulse width. So, by tinkering with the reference, output voltage can be changed, or at least to some amount. The control chip is located at high side, the dangerous side, and for safety reasons, the output and input part is strictly galvanically separated. The voltage difference is therefore transferred by light bridge, aka optocoupler. So here you can see the optocoupler, and this is the easiest way to locate the voltage reference, to look for an optocoupler. They all look alike, so it's 4 pins, and the separation, very good separation, also by drilling to the PCB actual. And near the optocoupler there should be a voltage reference, free elect part. So this is it. And here you can see the actual resistor that I soldered in, extra resistor. Alright, so this is the close-up shot. These three legs are the voltage reference, AS431. And these resistors are R1 and R2. These two are connected in parallel. The first one is 22D, which is 165 kilo ohms, and this one is 67B, which is 4.87 kilo ohms. So in total 4.73 kilo ohms. And this one is 56 kilo ohms, 5602. So the voltage reference equation is voltage equals 1 plus R1 over R2 times 2.5. And if I put these values, I get precisely 32.098 volts. Because this line is ground, so that's the way I found out this is R2. These two resistors are R2. And this is the empty space for an extra resistor, which was already soldered in the previous shot. And I calculated from this equation that I need to put there around 55 kilo ohm resistor to get 35 volts that I needed for my LED. In reality, it was a little bit less, but I tinkered with it with potentiometer. The driving chip is LD7522, and here also the voltage reference, and this is voltage divider from ground to plus. And now, despite crappy soldering and bad explanation, it works. All this kind of. Alright, so thanks for watching. I didn't really find any information about these power supplies, so I hope it helps. And of course, the voltage can be modified only in certain range.